Okay, so we are continuing. This is part 2 of the video. We're continuing on page 5. And we're talking about reflecting graphs, okay? So parent reflections, I'm on the left-hand side in the note. Reflections take the parent function and provide a mirror image of it over either a vertical or a horizontal or vertical line. So reflections in the coordinate axes of the graph of y equals f of x are represented as follows. So you know you have a reflection in the x-axis if your new function h of x is negative of your original function. Remember, the f of x is your parent function. I'm sorry, I shouldn't have put that in bold. Parent function. Okay, and it's a reflection in the y if h of x is equal to f of negative x, okay? All right, and so note the difference there. And this takes a little time to get used to. I would advise in that if you still are a little unclear to read the book on this section as well, because they'll have more examples. So compare each function with the graph of f of x equals the square root of x, right? And so again, get you some famous points on the square root of x. You can use 0, 0, you can use 1, 1, and you can use 4, 2, right? And so once you plot those, I would say get at least 3 points, 2 to 3 points. Then we see that this is negative f square root of x, so that means we're going to have a reflection in the x-axis. And so here's our x-axis here, and once you have those points, that's why I said it's so important to get you famous points on your parent function, because once you have those points on your parent function, then when you do it in the reflection in the x-axis, you know, and we talked about this already, that when we reflect in the x-axis, the x coordinate stays the same, but the y changes, right? It's the opposite. And so you'll have 3 points, and then you can sketch, and there we go. And if think about it, if you put a mirror on that x-axis, then it would show a mirror image of what's of our parent function, okay? Here we have a reflection in the y-axis. So notice the difference again. The negative was on the outside. For A, here it's in the inside, which tells us we're going to have a reflection about the y-axis. And again, use your famous points. We know that if it's a reflection of the y-axis, then our x coordinates change, but our y coordinates stay the same. And there's that reflection. Okay. Non-rigid transformations. So far what we've talked about have been considered rigid transformations. So shifts, vertical, horizontal shifts, and reflections, we call that rigid transformations. Non-rigid transformations are those that cause a change in the shape of the original graph. So if you shrink it, or I was going to say shrink. If you shrink your parent function, or stretch your parent function, then that's a non-rigid transformation. And it looks really technical for the definition, but don't let that intimidate you. This is just some advice on when you're stretching and shrinking and things of that nature, okay? And so if y is your parent function, then a non-rigid transformation is represented. So basically, if you are multiplying by a constant, if you're multiplying your original function by some number, then that's when you're going to have a non-rigid transformation. And all this is saying is if that number c is greater than 1, you're going to have a vertical stretch. And if the c is on the outside. So notice here, the c is on the outside, you're going to have either a vertical stretch if c is greater than 1, or if it's between 0 and 1, you're going to have a vertical shrink. Then your graph's going to shrink. And if c is inside of your function, so c is part of your input, then when c is greater than 1, it's going to be a horizontal shrink. And if it's between 0 and 1, it's going to be a horizontal stretch. Okay. And that's just repeating that. All right, so let's look at an example. So example 4, we have, and I would definitely, again, plot values, get your famous values. So here, my famous, I had, for my parent function, this is the absolute value of x. So the purple is my parent function, and I plotted some points on my parent function, negative 1, 1, 0, 0, 1, 1. And then on the new function, our coordinates, so just so we're clear on understanding this again, the coordinates for the new function, or points on the new function, would be negative 1, 3, 0, 0, still on there, and 1, 3. Okay, so see how it did, see how the 3 is on the outside of our function, and you see 3 is greater than 1. So if we go back and look, it said if C is greater than 1, you'll have a vertical stretch. So you see it's sort of stretched, right? It's stretched up vertically. Okay. And this one, B, compare the graph of g of x equals f of 2x with the graph of f of x equals 2 minus x cubed. So I actually want you to do this one on your own. You will either turn this in electronically, meaning you do it on your own, take a picture of it and upload it. I'm going to figure that out, or you'll turn it in when I return. But you're going to be doing this on your own. Plot as many points as necessary and identify the parent graph first. And to give you a hint on that, look at that x cubed there. So that cube should be a giveaway on what your parent graph is. And you have a couple things going on. So this is sort of different. Well, actually, so here's a couple things you have to do. First, identify your parent graph. Okay. Then, so identify the parent graph, then graph f of x. All right. So this is a little different. So identify your parent graph, then graph f of x equals 2 minus x cubed from your parent graph. Then if you were to plug in f of 2x, I want you to graph that. So you're going to have a total of 3 graphs on here. Plot some points. Make a table and plot points for each of these. You have your parent graph, which you should know what that is. Again, look at that exponent for a hint. You should have this graph right here. So you can let's call your parent. So call your parent graph h of x, okay, since h isn't being used. The letters can change, so don't worry, don't let that trip you up that the letters change. So let your parent graph be called h of x, okay? Call your parent graph h of x, and then graph f of x. There's a couple of things going on here because you got a negative, and then you got that 2, and then plot f of 2x, okay? All right, and that's it. So I am done with section 1.7. I will not be going back over this. We're going to continue to move on. So you need to make sure I may briefly answer any questions if you have any questions once you look at the homework. If you have any questions from 1.6 and 1.7, make sure you write those questions down. And I might take the first 10, maybe 15 minutes of class when I return on next Wednesday to answer them, but for the most part, these are your notes. So you are doing this, and I'm not going back over it when we get to class. I'm going to continue to move on. All right, bye.